Okay, Algebra 1, 6.6, the last lesson of the chapter. So yes, we'll be having a quiz soon. So this one is not graphing systems of equations. This is going to be graphing systems of inequalities. So what's going to happen here is that they're going to give you inequalities that you have to graph and find where the solution is. So let's start off real simple of recalling how to graph an inequality. So y is greater than or equal to 3x minus 2. We're going to go back and just graph one of these. So there was a couple of rules or steps that we had to follow. And I think that would be graph it or find the critical points, right, of a line. This one's in slope-intercept form. Ask yourself, is this solid or dotted? And then check a point and shade. Those were the three things that you guys had to take in consideration to graph this. Because remember, we're not talking about a particular point or value or line. We're talking about a range of points that will work, that will satisfy or make that inequality true. You guys remember that? So, I generally like to graph things that are in standard form, but this is in slope-intercept form. Well, let's go for it, right? So I go and I make my axes, trying to be as consistent as possible. And again, the reason I like standard form is because I don't have to worry about going up and over, using slope. Sometimes my line gets a little off going that way, right? So I want to keep things as consistent as possible. But this is what I've got. Where do I start? Izzy? Negative 2 on the y-axis, or the point 0, negative 2. Everybody okay with that? And so, now, I want to move slope. What's the slope? It is 3 over 1. So that means I will go up 3, 1, 2, 3, and over 1. Or down 3, 1, 2, 3, but back 1. And this should result in a straight line. Oops, sorry. Is this a solid or dotted line? Solid. It is solid because it's equal to. Okay? Now, we're not done with this inequality. We need to check a point to shade. Am I to the left or to the right? And we like to use what point? 0, 0. So I go back up to here. And why do I like to use 0, 0? It's the easiest, yes. Why is it the easiest? Bless you. Anything times 0, 0. It makes things disappear, guys. 0 greater than or equal to 3 times 0 minus 2. Or is 0 greater than or equal to negative 2? Is that true? Yes. So therefore, I shade the side that has 0 in it. Bless you. And you guys would shade to the left, and we're done. Yes? Yes. Now, if you were able to do that, could you do it again? Yes. So, here's the thing. We have one equation. We are now our inequality. What they're going to do is give you not one, but two inequalities. You know what? They could actually do this even worse, make it worse, and put 3 or 4 of them. It's perfectly fine. You just got to keep doing the same thing. Now, I have the liberty of changing colors. You guys might not have that ability. So you're going to have to be able to distinguish between your graphs. Now this one is in what form? Standard form. So if it's in standard form, you will graph using cover-up method. Put zeros in for x's and y's. Remember, when you put a 0 in for x, it covers up, and now you solve for y. Negative 3y equals 6. It's negative 2. When I put a 0 in for y, 2x equals 6. Divide both sides by 2. I get 3. Everybody should be fine with that. We should get to the point where that's starting to become second nature. If not, please stop in. Let's talk. Now, if I wanted to graph these, 3, 0 is there. 0, negative 2. Ooh. Hey, I know the solution to this. It's at 0, negative 2, right? Oh, wait.
Oh no, we're not done yet.
We don't have equations, we have inequalities. If these were equations, then yes, 0, negative 2 would actually be the solution to this. Here's the thing. I didn't even graph the line yet. Is this a solid or dotted line? It's a dotted one this time.
Pretty straight too.
Okay. And I still have to decide, do I shade up or shade down? And so, again, the nice thing about 0, 0 is 0 minus 0 greater than 6. Is that true?
No.
Because 2 times 0 is 0. That's why I put 0 there.
Yeah.
And that's not true. So if the top side doesn't work, I shade the
Yeah.
I shade the bottom side. So if I did not have 2 different colors, I may have to shade one kind of drawing lines kind of like perpendicular to my lines. So I might go something like this instead. And then on my red line, I would keep those perpendicular to that line. And then therefore, the true solution to this system of inequalities is where the points both work. Which means it's where the shaded regions meet or overlap, which is here. Boom. You're done. It's where the shaded regions overlap. Guys, let's think about this. If I chose a point from this area here, it works for the red line, right? Or the red inequality. But is it a solution to the blue one? No. So it's not a solution to the system. Vice versa over here, this point here is a solution to the blue inequality, but not the red one. And any points in this zone don't work for either one. So obviously they're not the answers. And any points in this double shaded region here, now triple shaded, work for both. So that those points are solutions to the inequalities. Now, I have a question. Is a point right here on this line part of the solution? Yes or no?
Yeah.
The answer is no. It's not a solution right here, which is, that is not a solution.
Why?
Because, is that line included?
No.
No. That line's not included, so therefore it's not part of the solution group.
Is the other one?
The other line on the other side, if I chose that point, since it's included in the line, it's also included in that group. It's part of the boundary. Is the boundary included? Then it's good to go. If it's not, then you're not. because it both satisfies the red and the blue. That's why it's a solution. The last thing I want to talk about is the fact that your systems can do some things that don't look necessarily right. So you might get something like y is greater than or equal to 4. But you might also get y is less than negative 1. Tell me the solution to this system. Wait a minute, guys. That's y equals 4 and y equals negative 1. Everybody with a show of hands, tell me what a y equals line looks like. It should be horizontal. X equal is
vertical, Will.
vertical. Okay? So, these, you guys, if you see x equals, or if you see y equals, or greater than or equal to, less than or equal to, you're happy. Because those are the easiest lines to probably graph. So, when I go to make my graphs, you can see that I should be at 1, 2, 3, 4. And is that solid or dotted? It's a solid line. And I need to check a point. I would like to check 0, 0, right? So the question is 0 greater than or equal to 4? No. So that means I need to shade up. The other one happens to be y equals negative 1. So, y is less than negative 1. Solid or dotted? Dotted. The question is now, is 0 less than negative 1? So that means I actually have to shade on the bottom.
Oh, so there isn't.
So what solution? Is there a solution to this system? No. There is no solution to that system. You guys seeing that? Because they'll never meet. Now, I'm going to change it. Is that okay? I'm going to back out that line. And I am going to go up to here. And I am going to change that to a greater than negative 1. Notice it's the same line, dotted line at negative 1, right? But this time, when I check 0, is 0 greater than negative 1?
Yeah.
Yes, which means I need to shade
Up.
up.
Oh.
Now is there a solution?
Yes, there is.
And the solution happens to be
Oh.
this part. Does it include 4 for y? Yes, because the line is included. So it always exists where they overlap. Any questions? Seems easy enough, huh?
Yeah.
So, your homework then is page 374. This is 6.6, 1 through 9. Have a great day.